Hey guys, congratulations for making it this far. Now we'll move on to a new part of database, and this aspect of database design and development. Usually people express a bit of angst and anxiety towards understanding and completely applying it. And to be fair, it takes a bit of understanding and practice to actually gather the concepts that are required for you to be proficient. So this part of database design has to do with relationships and foreign keys, and the bigger elephant that is always in the room when this topic is being discussed is normalization. Now, let me start off with relationships. Relationships are essentially what the word means. They speak about how data is related. Now, we would have started off the course by saying that we're using SQL Server, which is a relational database management engine or relational database. PostgreSQL, MySQL, there are a few others on the market that are also relational, and there are some that are not. So relational databases, they thrive on their ability to have relationships. And I keep on saying that relationships. So let me explain. Relationships are essentially talking about how the data relies on each other. For instance, if you look on my screen, you'll see that I have what we call a database diagram or entity relation diagram, which is showing entities in the tables in the forms of entities. So a table, once again, is the collection of different rows of different entities. So in database terms, the whole table is called an entity. All right. So this is a database I was working on outside of this course, but I'm just bringing this up so we have a bigger picture of a completed and fully fully normalized database. And so you see that each entity or table with all of its columns, right? And then you see that there is something here connecting it to another table. So you can see leaderboards is connected some way, somehow to the users table. Predictions is connected to the users table. And so this visual representation of relationships can help us to, conceptualize what purpose a relationship serves. So in a nutshell, it's literally saying that entities are connected to each other. All right, they share data, they share some dependency. You can't have one without the other, or it's very difficult to have one without the other. That's what this connection means. So we can have a user, and if you notice, the key is always going in one direction, right? So it is going from this leaderboards, and the key is pointing to users, which means you can't have a leaderboard entity without some representation of a user. You can't have a prediction in the system without some representation of a user. And the same for a match. So this database was being developed to be the storage mechanism for a World Cup prediction application. All right, yes, I built one of those in the past. And so people could log a prediction. So of course, when they logged a prediction, they needed to state which match it is that they were going to be making the prediction on. And so they had to choose the match. All right. And then we would have to know who is making said prediction. So of course, I had to keep a record of the user. And so that brings me to the second part of relationships, which is called the foreign keys. And this is all very high level. So of course, we'll be getting into more details as we go along, but I'm just giving you a high level representation of relationships and foreign keys. So a foreign key is essentially just the bit of data that you need to help you identify the related entity. And that's all Spanish. Let me just show you in practical terms, and then we can revisit that explanation. So let's stay on our predictions table. So we have a prediction. We all know that once we create a table and we're creating an entity, we need a primary key. And so that is depicted right here by this little key emblem. And we would have gone through creating tables and setting primary keys and all those things. So that shouldn't be foreign. And then we have a bunch of properties that we know we put on, and this doesn't display the data type, which is really immaterial in this setting, in this forum. So we have an ID for the prediction, and we know if it's an active prediction, or if it should be counted amongst the many. Any comment, that joker is just another property that was there. I'd have to explain the entire system for you to understand that, but that is not really important. And then you'll see something match ID. Okay. And if you notice, well, it's not always like this, so I don't want you to necessarily take this as a rule of thumb, but sometimes you'll actually see this connection originating directly from the primary key, or the foreign key rather. So in this situation, it doesn't. So that's not really something to go by, but you see that we have match ID, and match ID is the representation of the match from our other table. So in other words, it would be difficult for us to have a prediction and we actually spell out the match, because we're actually creating the matches here. We actually created a timetable for all the matches that are going to occur, and we store that in a table. It would be kind of foolish and redundant to keep on repeating all of these details so you know which match the prediction is being created on. All right. So what we did was have a table just for matches. And then what we do is give each match an ID. And then each time a prediction is made, we just reference the ID of the match that is being predicted. All right. So let me say that again. We have a table solely for one entity. It has no dependencies. A match can exist without having anything else. Well, in this case, a match needs a group. So you see that the match still needs to be associated with a group. And then the match can exist without a prediction. So the match table has all the matches. And then a prediction can only exist if a match is associated with it. So that is that kind of association. You always have to map out what bit of data can exist without any other data, and then figure out what needs this pre-existing data in order to actually survive. So let me use the users table, since this one has absolutely no dependencies. So a user is a user. A user exists, right? I can create a user tomorrow. I don't need anything else. In this case, I don't need gender or anything. So I just have a user who has either he's active, the date he or she was created, and certain contact information. And that's all I need on a user. However, to make a prediction, I have to say which user is making this prediction. So it would be foolish of me to create a prediction and write back the person's first name, last name, and username every time, or just the username, because then I might have a spelling error over here and the username is something over here, and then trying to match them back, that's going to cause problems. And when we get into more advanced queries with inner joins and so on, you'll understand what I'm saying. But what we do is we know that the ID is always absolute. The ID is always unique. So we want to reference this unique data point to make sure that we always know who is making a prediction. So we create the predictions table and we give the prediction all of its properties that it needs. But then we say, okay, for who is making the prediction, we just want to reference that person by ID. So that user ID here matches the primary key value here. So if the user is 1 here, then the expectation is that when user 1 makes a prediction, all of this gets filled in, and 1 would be the value here. When user 10 makes a prediction, everything else gets filled in, and 10 is the value here. So if we look at who made the prediction and we see user ID 10, I can go back to my users table and I see 10 and I see, oh, Trevor Williams created that prediction. So that is the relevance of a foreign key. The foreign key cuts down all of the repetition of data across the tables and allows you to have a unique reference point between two tables and whatever data needs to be shared amongst them. All right. So that is the example with predictions and users. So in the same way with the matches, the prediction can only exist on a match. So instead of saying, oh, we're making a prediction on team 1 and team 2, and then somebody comes along and makes the same prediction on team 1 and team 2, and then we repeat that again for that entry, then we say this prediction exists on match ID 5. If we go to our matches table, we can see match ID 5 and get all the details here. So we don't have to repeat the details across the tables. And that principle is also called normalization, where you're looking at repeating data and reducing it. So that is why this video is called Relationships, Normalization, and Foreign Keys, because they all go hand in hand with each other in reducing redundancy and repetition again across tables. So pretty much the only repetition you should have would be your foreign key values, because if user 10 makes 10 predictions, then you'll see 10 predictions in the database having that repeated ID. However, the details of user 10 only appear once, and that's in one place that we can go to. All right. And that is essentially, in a nutshell, that is how foreign keys, normalization, and relationships work. For the rest of this section, we'll actually be looking at creating tables and creating relationships, and we will build on the database that we have already started, and we'll start looking into more advanced database concepts. See you soon.